In this video, we'll configure the discrete variables on the M340. We'll open our bus. For this problem we're working on, we'll have two input switches, a start and a stop button. Those will be connected to the DDM module, so let's configure those first. So we right-click to open that module. If we click on its description, here we get an overview of what the module does. It's a 24-volt module. It has 8 inputs, so those are 8 24-volt inputs, and 8 outputs, so those are 8 transistor outputs. Click on the I/O object tab, and it lists a collection of different types of variables that the module may possess. It won't possess all of these. It's an input module, so it will have inputs. If we select that and click Update Grid, it lists all the inputs. So it has inputs 0 through 7, so those are our 8 inputs. This module also has outputs. If we select this and update the grid, we get the outputs as well. Now, we don't need the outputs, so I can get rid of those. If we want to connect a start button to input, to our first input, we just select it, go over here, calling it start. We can add a comment if we want. And then create it. Okay, if you select the channel 0, that gives us a list of all the inputs. So our first one is the start button. If you select channel 16, those are all the outputs, and there's nothing there yet. Now there's another way we could do this, and that's to go over to the variable menu over here and select elementary variables, right click and open that. Gives us another window, and in there we can see that the start button has already been entered. We can enter our stop button in here, and it enters it, and by default it enters it as a Boolean, and what we want is to be what's called an eBool, which is an extended Boolean, and it operates like a Boolean, but it gives us more features, and we'll learn about those later. Now, the one drawback to doing it this way is that you have to remember what the address is. You have to be able to figure it out. Now, the addresses all follow the same format. They start with a %sign. If it's an input, then it's an I. If it's an output, then it's a Q. Q stands for transistor, but the Q is used whether it's a relay output or a transistor. So any output, any discrete output is a Q. Then the next 3 numbers, first number is the rack number. So we've only got one rack, so it's a 0 point. Then it's the slot number. So this card is in slot number 2. So a 2. Now this is actually the third card, because there was the processor, then there was an analog card, then there was this card. So it's actually the third. And then the actual input number, which is going to be number 1. And we'll add a comment. And enter. Okay, now if we go back to our module, that should show up. There we have our start and our stop. Look, the module there, our comment, everything shows up there. Okay, the other variable that we need is an output to control our pump. Open the relay module. So these are all outputs. So this module has 8 relays. There we go. It's got 8 relays. It'll handle 24 to 240 volts AC or 24 volt DC, and it's 8 independent relays. Okay, we'll start with the first one, so we call that pump. And this output will control our pump motor starter, which operates on 120 volts. Okay, we can check. Yep, it shows up there. If we go back to our list of variables, we've got our start, our stop, and our pump. So we've got everything entered. If we wanted to, we can enter a value in here, which would be the value that variable would have when the PLC starts processing, when you first turn it on. We don't need to worry about that for this problem, but we'll probably deal with that down the road. There, I guess we're done with that one.